Now this problem is based on the kinematic equations. A rubber ball is dropped from a height of 1.6 meters. If it loses 1/4 of its velocity on hitting the ground, to what height it will rise to rebounds, to rise in rebounds. Okay. And now let us do this problem. The ball is dropped from a height of 1.6 meters. It is falling down. So downward direction as a negative, I will take 1.6 meters. Okay. And then initially the object is at rest. So VA is equal to 0. And then we have to find out VF. VF is the just before hitting the ground, what will be the velocity? That is the first part of the question. Then next, what happens after hitting the ground? This is the ground. Okay. And after hitting the ground, the ball rebounces. It goes up. While going up, he gives the data as initial velocity VI is equal to this velocity minus VI minus 1/4 VI, or I will write here as 3/4 of the velocity, initial velocity. That means what is happening here? It is losing 1/4 of the velocity. That is why it has the velocity of 3/4 V, this VF or whatever it may be. Okay, let me write it as VF. Now we will then at how high it will rise. Initially it is 1.6 meters. So next, how high it will rise with this velocity. Now let us write the data. VI is equal to 0. And then acceleration due to gravity A is equal to G is equal to minus 9.8, because downward direction I am taking as negative. So it should also be taken as negative. And then VF is the question mark. We will use the kinematic equation. VF square is equal to VI square plus 2AD. Here height H is equal to D is equal to whatever it may be, displacement D is equal to 1.6 meters. I'm taking the 1.6 meters as negative because it is falling down. Now VF is equal to, this is 0, VF square is equal to 0 plus 2AD. Or VF is equal to square root of 2AD. That is equal to square root of 2 into minus 9.8 into minus 1.6. Okay. Now what will be the answer? 2 times this one. 31.36. Square root of this will give 5.6 meters per second. So plus or minus 5.6 meters per second. Okay, as it is coming down, I will take the negative value for the VF, and then while going up, it is the positive direction. Okay, so now VA dash is equal to this 5.6 meters per second minus 1/4 of the, loses 1/4 of the velocity he is saying now. So 5.6 meters per second. So this gives 3/4 times 5.6 meters per second. 3/4, 5.6 is equal to, we have 4.2. VA dash is equal to 4.2 meters per second. As it is going up, it will be the positive sign. Okay, plus 4.2 meters. And I will take the G is also the same. And then now we have to find out the H, height, how high it will rise. We use the same formula. So here I will write VF dash square is equal to VI dash square plus 2AD. Here VF is equal to 0. VF dash is equal to 0 because at the maximum height, velocity is equal to 0. At the maximum height, V is equal to, velocity is equal to 0. Now VA is known to us, and then we have to find out D. I will rewrite the equation. Okay. minus 2ad is equal to VA dash square. Okay, so minus 2 into A value is minus 9.8. And then D value, it is going up. We have to find out D is equal to, what is VA dash? 4.2 meters. Okay, per second, 4.2 meters per second whole square. So this is D is equal to, therefore D is equal to 4.2 meters per second square. All right, 4.2 meters per second square divided by, this is 2 into 9.8. Minus minus cancels out, this becomes less. Now calculate this one, 4.2 square divided by 19.6, get 0.9 meters. So the ball will rise to a height of 0.9 meters after losing the, because it loses some energy, that is why it will not rise the same height. It is rising up to 0.9 meters, less than a meter. Okay. So here this this problem is based on the kinematic equations, especially Vf square is equal to Va square plus 2ad. Hope you understood the problem. If you have any doubts, put in the comment section. I will help you. Thank you. Bye-bye.